Hey everybody, welcome to the, not lecture, but the, I don't know what to call it even. I'm going to go through the Chapter 3 practice test with you, problem for problem, step by step in here. So this, I think, will be extremely helpful in your preparation for the Chapter 3 test. So this comes from this page right here. That's page 163. Page 163. You can follow along in your books if you'd like to. I have just taken the little snapshots of each section of questions, and we'll work through those here together with you. A lot of these questions I am looking at for the very first time here, so I may end up pausing every once in a while and just thinking about it a little bit more so my explanations can be complete and thorough and concise. But let's get started with number 1 here. So exercises 1 through 3, write the statement in symbolic form. So we got P, Q, and R, and let's see what we got here. So Ann is the secretary, but Elaine is the president. And then remember, our commas is kind of like where we have parentheses. So let's work that through down here. I'll go with number 1 up here. Number 1 would be like this. So Ann is the secretary, P, but Elaine is the president. That would be but we think of as and. So P and Elaine is the president, that's R. So Elaine is the president right there, that's R. Or, so we have our comma, so this goes together here first. Or, Dick is not the president, or Dick is not the vice president. Or, so or looks like this. Or, Dick is not the vice president. He's not the vice president, so that's going to be not Q. So that would be it for number 1. I'll box that in as my final answer. No real work to do with that one beyond what we just did there. So number 2. Number 2, if Elaine is not, or is the president, then Dick is the vice president, or Ann is not the secretary. So if Elaine is the president, then Dick is the vice president. That's a conditional statement. So I know I'm going to have an arrow like that right there. So if Elaine is the president, that's R. Then Dick is the vice president, that's Q. And then I have a comma right there, so I'll put this in parentheses again. So I've got R implies Q and a comma, or, there's or Ann is not the secretary, or Ann is not the secretary. That's not P, all right. And then number 3, so box that in right there. That's it for that one. It is false, so I know what to do there. I put a not, and then I put my parentheses there. It is false that Elaine is the president. So Elaine is the president, that's an R. And then if and only if, I see that double arrow when I do if and only if, Dick is not the vice president. So I have not Q. All right, so I got that there. That would be it. I don't have to do truth tables for these. It just says to write them in symbolic form. So I'm going to pause it for a second, just double check those answers, and then move on to the next one. Okay, so it looks like I was all good. I checked my answers in the back. The appendix, page 13 in the back there. You can check your answers there as well. All right, let's check this one out now. So it said in exercises 4 and 5, use P, Q, and R as above. I just recopied that over here. So this is still using the P, Q, and R from 1 through 3 to write each symbolic statement now in words. So we're going to take this, we're going to take these and write it in words. So it's kind of the reverse of what we just did. Number 4 would be, here's P, and I see if and only if. So I would say Ann is the secretary, and it says to write it in words, so let's write the whole thing out. Ann is the secretary. And then that double arrow would mean I would write if and only if. And then we have Q and R together. So if and only if Dick is the vice president, and I'll say VP is okay for that one. So if and only if Dick is the vice president, and this would be and Elaine is the president. And again, notice I'm not doing truth tables here. It doesn't ask me to do that. It doesn't say I have to determine whether the statement is true or false. I just have to write it out. Okay, number 5. Moving on. That looks like it is false to me. I've got the negation and then parentheses, so it is false that. And then P implies not R. So if P, then not R. So if this is false, that if P is Ann is the secretary. So if Ann is the secretary, then not R. Then Elaine is not the president. Okay, and again, I'll just pause and double check. We'll move on if we're good to go. Alright, so when I check my answers in the back on this one, technically I could put a comma here. That might be a good thing to do. Honestly though, if and only if is kind of a dominant thing, so that would be more the last thing I'd do if there were no parentheses there. So I would do these two things together first, but I think the comma could be helpful there. So Ann is the secretary if and only if, and then it is false that if Ann is the secretary, and then usually if then statements, we'll see commas with them a lot, so you could put a comma in there too. That's what the back of the book has, and so I'll add that in there as well. So moving on to the next problems. 6 and 7, construct a truth table for the given statement. So let's work on 6 over here. First of all, I notice I've got a P, a Q, and an R. So this one is going to be one that has, use that. Let's go with blue here. It's going to have 8 going down here, and I want to make sure I have enough room for all that. So I got 8 there, and over here, oops, there we go. And I want to compare. Let me move. I think I can move that up. I think so. Grab it, grab it, grab it, grab it. There we go. All right. And let's make a couple more columns. I meant to do that earlier. So still use blue here. And I'm going to extend mine out this way a little bit. Nope, not like that. Come on, come on. There we go. That's good enough. Let me just draw another line right there, another line here. Okay. And so I'll put my whole statement over here. Let's start writing this one out. So let's say here we've got P, Q, and R right there. P, Q, and R. And we know by now, I hope, that we will have 4 truths, 4 falses. To start with the P, when we have 3 statements like this, and then we'll go true, true, false, false. While I'm thinking about it, let me make some yellow lines here, just so that it's easier to read, easier to see what goes with what. So yellow, there we go. You can see, yeah, you know what school this is. Maize and blue, baby. Go blue. Alright, I'm a big Michigan fan, in case you didn't know that. I love the University of Michigan football, basketball, all their sports. That's who I'm going to root for before anybody else. Just because they're better than everybody else. Yeah, that's right. We won't talk about that Alabama loss this year. We don't need to mention that. So yeah, that never happened. I wasn't there. I didn't see it, so it didn't happen. So this is, well, no, let's not use yellow. This is now true, true, false, false, true, true, false, false. So every other for that. And with R, we have true, false, true, false, true, false, and true, false. Okay, so let's do what we got here now. So we have not. This is all in a bracket here, so that's like my outer parentheses. Not, and then P applies R. And we have that and Q. So let's keep these in order. Let's label these in order. I'm going to be doing which one first? Well, this is going to come last because I'm going to do my parentheses first here, and then I would compare that set of parentheses, the whole thing, to this statement Q. So I know that would be last. So I'm going to do my inner parentheses first, so I'd have to do the P and the R first. But I've already got P and R right here, so I don't feel like there's any reason to rewrite down P and R again. I'm just going to do the if P then R. I'm going to do that first. And then I'm going to take the negation of that. I'm going to do that second, because that's the outer parentheses. Once I have that, once I have the negation, then I have this whole thing, so I can compare the whole thing to Q. I've got that there, and then I'm going to compare. When I compare 2 and 3, I will get my final answer here. I will get row 4. So this is what I'm looking to fill in last on this one. Alright, so let's fill in the rest. So this is going to be P implies Q. So look at P, look at Q. If there's ever a true to a false, that's the one that's false. That's the ones that are false. So this one is false, and this one is false. The rest, I don't have a true to a false. I have falses to anything is true when I have conditional, and trues to trues are true. So I've got 6 more here that are all true. So if I take the negation of this now, that's what I'm doing here, that flips all that. That switches all that to what you see here. And I got to put that last column in there. There we go. And so now I have Q. I'll rewrite that again just to make it a little easier to see, but honestly you could compare this row to this row and fill in that row too, but I'll just rewrite Q since I already went through the trouble of writing down that as 3 down there. So I could say this is true, true, this is false, false. Now compare this and this. Compare row or column 2 to column 3. They gotta both be true for it to be true with and. So I've got true and true. And that looks like the only one to me. The rest, I don't have both with the rest. So the rest of these will be false, 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 and false. Alright, so let me pause, just double check that one. We'll move on to 7. Alright, bada boom, bada bing. We are good to go on that one. And let's do another truth table. Oh, let's see, I'll go with purple on this one. How does that sound? This will be number 7. Over here, we want to do the same sort of thing. I'm going to got to use my P, Q, and R again. Got 3 statements. So here's P, Q, and R. That's neat for there. I'm going to make my 8 lines, my 8 rows. You've already got blue lines on your paper most likely. So I will insert mine here. That's going to be 1, 2, 3, 4, 5, 6, 7, and 8. Alright, that'll help me keep it straight there. And let's put this in now. P, Q, and R. So getting practice with this again. Hopefully you're a truth table professional by the time test day comes around. Truth tables, I don't think are hard once you know the rules. You just got to memorize those rules. Remember what each thing is or what each situation calls for. So now, same as before, I've got all that, and let's work this out now. So I have Q if and only if not R or P. Q if and only if not R or P. Let me close my parentheses there. And let's see what we should do first here. I see parentheses, so I'm going to do that first. With this one, I'm going to rewrite it here because not R, that could get a little confusing trying to do all that in your head. So I'm going to rewrite not R right here, and I'll rewrite Q right here. You could just write not R and then look at Q here. I think that'd be fine too, but just for the sake of not simplicity, whoops, that is not what I want there. The sake of just easiness on understanding, ease of understanding. That's what I'm looking for. Just for ease of understanding, we'll write it all down here. So I've got this is all just switching around from R to not R. Everything switched around there. And then Q, I'm going to rewrite what I saw there for Q. True, true, false, false. All right. So this is going to come third now. and then I'll do this P fourth after that, and then I'll do this OR last. So this, let's see, if and only if they either both had to be true, or they both had to be false to be true. That was the rule for biconditional. So that one's true, that one's true, that one's true, and that one's true. The other ones are false. And then P, let's rewrite that here. We got true, 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 false, 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 and false. Now I'm comparing 3 and 4. Why don't I circle those just to make it a little clearer what I'm comparing. I'm comparing my 3 right here with my 4 right here, and what I got over here will be my final answer in this column. So this or this, just one of them has to be true for the statement to be true. And so I've got one true there, so that's true. I've got both true there, that's true. I've got both true, that's true. Got one true, that's true. None true here, that one's false. This one is good, true, and the other two are, looks like false and false. And that's why I checked my answers. I went a little too fast on that one. There we go, erase that. I think I looked here and here when I should have looked here and here. So that was true and false. That's at least one being true. That's going to be true. I think from there that should match up. There we are. Okay, so that's good to go at this point. All right, let's do 8 and 9 here. Find the truth value of this statement. So we can look at these ones and just say, hey, this is a true statement or not, and then go from there and decide what we think from there. So let's write this out in symbols first. I think that's going to be easy way. Well, do we need to write this out in symbols? I can kind of just write on here and show you what I'm doing this. So I have this statement. Let's call this statement right here. Let's call that P. Or we're going to have P or, and then let's call this statement Q. So is P a true statement? Is 2 plus 6 8? Is that true? Well, yeah, that's true. So we have true or, and I already know since it's just or, that's going to be true. So 7 minus 12, though, that's not 5, it's negative 5. So that's true or false. But one of those, at least one of those is true. So that number 8 is true. Number 9, if you call scissors can cut paper, let me erase some stuff up here. So let's get rid of that. Scissors can cut paper, that is a true statement, so I would say true for the first part. And we have or a dime has the same value as 2 nickels. So this or 2 nickels, same value as a dime, that's true. True or true. And then I see a comma, so I'll put that in parentheses. And this is supposed to be if and only if, so biconditional, double arrow. If and only if Louisville is a city in Kentucky. Louisville is a city in Kentucky. You can verify that by looking at a map or atlas or looking it up online. And so we'd have true or true if and only if true. This part would become true because true or true is true. And then true if and only if true. If they're both the same, we say it's true. If they're different, we would say it's false. And so I'm good to go with both of those. All right, let's move on to 10 and 11. Given that P is true, Q is false, and R is true, determine the truth value. So another pretty quick one here for 10, I would say. So R, we're saying is true. So let's say we have, there we go, we have R is true, or Q. Q is false. So true or false, if and only if. And then P is true, and not Q. So not Q would be the opposite of Q. Not Q would be true. Since Q is false, not Q would be true. So we have true or false, that's true. If and only if. True and true is true. They're both true, so the statement is true. And then these are both true, so the biconditional is true. So this one, in the end, is a true statement. Number 11, we are supposed to determine the truth value of the statement here with this one. So we've got, I see 2 sets of parentheses here. So let's rewrite what I got there with T's instead of R's, T's and S instead of R's, P's and Q's. Oh, let's see. R is true, so I'm going to plug in T right there. Not P is going to be false since P is true. And then I'll close my bracket. I've got this, and then Q implies P. Q is false. And P is true. So let's break this all down and see what we got. So we're going to do, I would do this first, inner parentheses first here. We'd have not, and then true implies false. That's the false one when you have a conditional statement. So not false. I wouldn't really need to have the parentheses anymore, but I'll just, or the brackets. Brackets are just special parentheses, but I can have that. So false to true, that's a true statement. So I can write that without the brackets. I have not false and true. Not false is true. So I have true and true, which is true. They're both true. For and, they both have to be true. So let's continue with number 12 here. Determine which or whether the pair of statements are equivalent. So determine whether they are equivalent. So on this one, I notice De Morgan's law would definitely come into play here. I could do truth tables and do it that way, but if I see a shortcut, I might as well use that shortcut. So I know one of De Morgan's laws was that I could have this. I could have not, and then I could have P and Q is equivalent to not P or not Q. So both can't happen at the same time. So not P or not Q would have to happen. One of those two things would have to happen. So I'm going to apply that to this right here, and let's see what this becomes. So according to this, I would have with this not P and not, I should say not, and then in parentheses P and not Q. This would be the same thing as saying, you could say not P or Q. So we're going to take this and negate that. Negating something that's already negative is going to make it back into a positive. So this looks exactly the same as that. So are they equivalent? Yes, they are. So this is equivalent here. This is equivalent. Boom. Dot those I's. All right. Let's check out number 13 and 14 kind of go together. So 13 and 14 determine which, if any, of the three statements are equivalent. So let's go. Looks like a good idea here would be to label some of these things, or at least to know what they are. So I would say, let's call B for bird. Let's do that. Is red. So if the bird is red, then it is a cardinal. Bird is not red, it is a cardinal. Bird is not red, then it is not a cardinal. So let's see. If the bird is red, then it's a cardinal. Let me think about this one for just a second. Okay, so there's basically two statements here. The bird is red, and the other simple statement, it is a cardinal. That's all we have here. And I'm going to go with R instead. I said B earlier, but R for red. So red implies cardinal. That would be here statement A in symbols. So part A would be red. If red, then cardinal. So I'll use R and C for bird is red, it's a cardinal. B would be the bird is red, is not red, or it is a cardinal. So this is not red, or it is a cardinal, or C. And then C would be if the bird is not red. So if the bird is not red, it's going to look like that. Not R implies that it is not a cardinal, not C. Alright, so we can go from there and think of what we got. We may be using some truth tables. We might be able to use some shortcuts here. Alright, so up here I'm going to write De Morgan's laws and see if any of these apply. So De Morgan's laws, I should put a little apostrophe S there. De Morgan's laws, and then here I'll write my conditional equivalence law. That's what I called it. It didn't say that in the book, but this is on page 131. This is on page 133. You can refer back to that. So the first thing, Morgan's law, we saw that one of them in the last example there, but first thing there, let me write that without the circle around it so you don't think it's a new problem. This is the first law there, was not P and Q is equivalent to not P or not Q. And then the second one they had was not P or Q, so neither P nor Q is equivalent to not P and not Q. And so that might apply. And you also had the conditional equivalence law. That was P implies Q. That would mean either that's going to be equivalent to either not P is happening or Q is happening. Because if P happened and Q didn't happen, then that wouldn't be a true statement. That was our true to false one. So if this is true, that has to be true as well. So do any of these apply down here? So I see A, R to C. That's like here, P to Q. That is supposed to imply not P or Q. So I see A and B based on that being equivalent. Could we do a truth table for that? Sure, if we didn't see that. But I can definitely tell that these two, just based on looking at my laws here, these two have to be equivalent based on that. So these two are equivalent. Let's see if then these other two would be equivalent. So it looks like this is another conditional statement. So this should, if this is equivalent to this, and this is equivalent to this, they're all going to be equivalent to each other. So let's check this one to this one and see if that follows. So not R implies not C. According to this, not R implies not C would become R or not C. You'd fill it in like that, and I see not R or C. So this one is not equivalent to this one, and if it's not equivalent to that one, it can't be equivalent to this one either. So this one is not going to work out. It's just these two that are equivalent. Could you do truth tables to find out all of that? Of course, but we saved ourselves, I think, a little bit of time by knowing our shortcuts up here. All right, let's do number 14 as well here. So it is not true that the test is today or the concert is tonight. So let's go with test, concert. We use T and we use C. So it is not true is the same as saying it is false. And this is part A. Let's put that down here. This is part A. So it is false is the same as saying it is not true. It is false that the test is today. So we'll say T is the test is today, or the concert is tonight, or the concert is tonight. We'll say the concert is tonight is C. So that is that one in symbols. The test is not today and the concert is not tonight. That would look like not T and not C. And then part C here would look like if the test is not today, that would be like this. No test implies the concert is not tonight, implies not C. So let's look at these shortcuts again and see if we have any equivalent statements here. So I've got not T implies C, and I've got this here. Sorry for the pause there. I just had somebody staring through my window even though I have a note on the door saying not to disturb me. Okay, so I have this and this. I look at these two and I look at this second one up here. That looks like this applies to me. So not P or Q. I have not T or C, just different letters. And so does that imply that not T and not C is going to happen? Yeah. It's false that neither this nor that is happening. Then we have this being true. So this is equivalent. A is equivalent to B. Alright, is that the only one? What do we see here? So I see this. You can use the conditional equivalence law here. This is a conditional statement and test it out there. So not T implies not C. That would become either, you should have the opposite of that now. You should have T. This would be the same as T, or, and then Q stays Q. There's no change in that, or not C. So does this look the same as this? No, it doesn't. Since this is not the same as this, that's not going to be the same as that either. So this one, that's another one that doesn't work here. So just A and B work again. And if you wanted to verify that with the truth table, or if you wanted to just use the truth table instead, you could totally do that. That would be another fine way to do it. Alright, we're getting close. Number 15, let's see what we got for this one. Translate the following argument into symbolic form. Determine whether the argument is valid or invalid by comparing the argument to a recognized form or by using the truth table. Alright, so let's see what we got here. If the soccer team wins the game, then Sue played fullback. If Sue played fullback, then the team is in second place. Therefore, if the soccer team wins the game, then the team is in second place. I think this one is going to be a good idea to write these down as statements like this. So let's go with, we'll just use P, Q, and R this time. So if, let P be the soccer team wins the game. Let's go with Q being Sue played fullback. And let's say R is the team is in second place. The team is in second place. Okay, so we're translating this into symbolic form. So if the soccer team wins the game, that would be P. Then Sue played fullback. P implies Q. Alright. If Sue played fullback, then the team is in second place. That'd be Q implies R. And it says therefore, so this looks like this. This is where we're kind of, in a sense, adding the two statements together. We're saying this and this happening is supposed to, if this is a valid argument, it's supposed to imply that if the soccer team wins the game, that implies then the team is in second place. So this one, you probably could have read that and said, okay, I noticed that what that one is. So this is I want to look it up in the book and see what they called it again. I remember what it is, but I don't remember the name they call it in this book. Okay, yes, as I thought, law of syllogism. So just wanted to double check that and make sure before I said the wrong thing. So law of syllogism says if P implies Q and Q implies R, a first thing implies a second thing, that second thing implies a third thing, we can go right from the start to the end and say that. So this is valid by the law of syllogism. Now, could we have done truth table stuff to verify that this was a valid argument? Yes, we could have done that. So law of syllogism, but if we can use one of those shortcuts, might as well do that. Might as well use one of those shortcuts if at all possible. I do feel like I should remind you, though, before we move on of this, of what a truth table would look like for something like this, how you could check something like this. This one I'll just do a quick freehand guy here. I'm not going to fill in the whole columns. But this would be, there we go, P, Q, and R. You do all that stuff here. You'd have your 8. And then remember, you're saying this is true and this is true implies that this is true. So you'd start with something like this. P implies Q. You'd want to check that, and Q implies R would have to be true as well. Both those things being true is supposed to imply that P implies R is true. So you would have something that looks like this, and then you could fill out your truth table from there. But you'll notice, I think, very quickly that would this take a lot more time to do than to just look and say, oh, that's the law of syllogism. Of course, yes, this is going to take much more time to do than to fill out this whole truth table. So no need to do that, but you could do that. You could fall back on that if you had to. All right, let's move on to 16. Let's see what we got here. Is this true? Use an Euler diagram to determine whether the syllogism is valid or a fallacy. So is this valid or is it a fallacy? All cars have engines. Some things with engine use gasoline. Some cars, therefore, some cars use gasoline. So let's draw our table here, or our diagram, I should say, instead. Let's draw our universe. Whoa, that looks pretty sweet, but I can change that quickly, I believe. I can click on it here. I'm just going to delete that. That's not how I did not mean to fill that in. Let's go back here. That should not be filled. There we go. I got that selected. I got that selected. And now I'm ready to draw my universe. Okay, that looks much better. And now this is going to be my U. Let's go with the red, and we'll go with, see, that's, hey, I selected red, and then it deselected it. That's part of why I'm messing up all the time, huh? Alright, so all cars have engines. So all cars have engines. I could have a little circle inside of a big circle. Whenever I have all something, I can do something like that. So I have all cars have engines. So within the car circle, or within the engine circle, I have all cars inside of there. So I'm going to say C for cars, and I'm going to have E for engines. And so remember, with these things, we're trying to find a way or draw a way where it doesn't have to be true. That's always what we're trying to do here. So let's go with green. Some things with engines use gasoline. So some things with engines use gasoline. And so this would go, I've got that ready to go here. Some things with engines use gasoline. I forgot to change that again. Change it back again. Green, there we go. And so this would be a possibility. Some things with engines use gasoline. I could have cars included in there as well, but I don't have to, according to this at least. So I could do something like this. Some cars with engines use gasoline. Or some things with engines. I can't say some cars, but some things with engines use gasoline. That's what it says up here. So I could do a little G in here, and then that would make this second premise hold. That would be a valid second premise drawn like that. That's one way I could do it. So is this true? Therefore, does that have to be true? Do some cars use gasoline according to this? Well, we would say in real life, well, yeah, that would be true, but we're not talking that. We're talking about what we're given here. Based on what's given to us, is this a valid argument? And from there, I would say, no, it's not. Because, according to this, I could have this as a possible way to draw it, to make that true. So is this valid or invalid? This is invalid. Because I don't have to have some cars using gasoline according to the way I drew this. Alright, and let's move on to some of these last ones now. So 17 and 18, writing the negation of the statements, all leopards are spotted, starting with that for number 17. Okay, so we didn't really talk about this too much in the examples we did together in our notes so far, so good to go over this here instead, or in addition to what we've already done. So write the negation of the statement that all leopards are spotted. So if all leopards are spotted, well, if there's at least one that wasn't, that would be the negation of that. That would be making that a false statement, basically. So we could say that instead of all leopards are spotted, if we said some leopards are not spotted, that would be, in a sense, the opposite of that. If there's at least one that's not spotted, this no longer is a true statement. So some leopards, some leopards, some leopards are not spotted. Some leopards are not spotted. And then number 18, for the same sort of reason, we can come up with a negation or the same sort of thinking process here. Some jacks in the box are electronic. So if there's some that are, if there weren't any, that would be the opposite of that. If we have at least one that is, but then all of a sudden we didn't have any, that would be the opposite. So this could say, or we should say, no jacks in the box are electronic. Try to say that 10 times fast. Jacks in the box. No jacks in the box are electronic. If you said it 10 times fast, try to say it 23 times fast. So no jacks in the box are electronic. And here is 19. So write converse, inverse, contrapositive of this statement here. Alright, so 19, we are doing, the conditionals are already here. So the converse What do we do with the converse again? Well, I think of shoes. I want to switch brands to Converse. I want to switch the statements around. So it's pretty simple. We just take our first part, our second part, our antecedent, and our conclusion, our consequent, I should say. And all right, I'm back. Sorry, I just had another interruption there. Even though there's a sign on the door that says "Don't disturb," the janitor came in and did his job, so I don't blame him for that, I guess. But now he knows what I'm doing, making videos in here. So I've got the converse, inverse, contrapositive. So converse, if we're going to switch these around. So we're going to say if today is Saturday, then the garbage truck comes. And we're also supposed to write the inverse, so let's do that now. Inverse. And we take the original statement and just put nots in there. If nots are already in there, then we take them out. So we negate what's there. So this would be if. And then in a grammatically correct way, we would say if the garbage truck does not come. So if the garbage truck does not, you could say doesn't as well, but I'll write out does not. If the garbage truck does not come, then today is not Saturday. So I took my original conditional statement and just added the nots in there. And the contrapositive, when I do the contrapositive, I usually look at the converse and just take that and put nots in there. So that's, I think, the easiest way to do that. Contrapositive would say if today is not Saturday, if today is not Saturday, then the garbage truck does not come. And hopefully you remember from our previous lessons that the conditional, the original statement, and the contrapositive are equivalent, and also that the converse and inverse are equivalent statements. And so let's see, number 20 here, is it possible for an argument to be valid when the conclusion is a false statement? And we're supposed to explain our answer even though the back of the book doesn't explain our answer. So they say, and I knew this thinking about this question before, that it is, yes, this is possible, but why is this possible? Thanks, back of the book, for not doing what you asked for. Boy, that's terrible. So I will explain it here though. Why is this possible? For an argument to be valid when the conclusion is false. Well, the conclusion, that implies that I have an implies arrow. That implies that I'm supposed to have something like this. But we know that if we have T to F, that's where it's false. That's where it's not going to work. But I could have, if this first part was false, then I have a false to false statement becoming true. So that would be a valid thing to say. If the first part was false, the hypothesis in a sense was false, the conclusion then is going to be, we're told the conclusion is false. It's a false statement. If it's false, false, that's one where you have that being true. So that is the last of it. I've got one more thing to mention here. So for more practice, if you want to work through some more problems on your own to see if you're ready for the test, go to these pages in your book, and all the answers are in the back to these. So check your work as you go. You can do a few more there. You could go to very specific lessons that maybe you were weaker on and practice some of those problems. And make sure you're ready for that Chapter 3 test coming up. All right, and so that's all. I just wanted to represent the college today. I'll be wearing a lot of college shirts making these videos and stuff. So UCLA seems like a good place. I'm not really a UCLA fan or a USC fan. I'm a Michigan fan. We know about that from this one back here. You found out all about my pride. Go blue, go blue. So UCLA, okay, not bad, but I'll wear the t-shirt at least. But Michigan is where it's at.